So for this first problem, we have a pretty classic problem that at least some variation of it always tends to show up on the SAT. We have a circle and we have angles inside the circle. We're told that P is the center of the circle and we're asked to find the value of the angle X. So how do I approach this kind of problem? The way I like to think about this is you're given that you have some circle, and the property of circles that we really want to take advantage of is if you have any line that starts from the center of the circle and ends at any point in the circumference of the circle, that line has length equal to the radius of the circle. Now, we may not know what the radius of the circle is, but in this case, it actually doesn't matter. So this line has length equal to the radius of the circle, again, because it starts from the center of the circle, P, and ends at the point B, which is on the circumference of the circle. And same for this line here from P to C. Something that I notice immediately is that we have a line from P to B and a line from P to C, but we don't have a line from P to A. So I'm going to go ahead and draw that in. So the line from P to A, that is also a line from the center of the circle to a point on the circumference, so that also has length equal to the radius. And in other words, these three lengths, A to P, P to B, and P to C, therefore all have the same length. So the way I'm going to denote this is by annotating it like so. Now, what you'll notice is as soon as I draw this line AP, you can see the formation of two triangles. This triangle APB and the triangle APC, right? And recall from the base angles theorem, so the base angles theorem. So the base angles theorem tells us that if we have any triangle, such that we have two congruent sides, or two sides of the same length, and we have two corresponding angles theta 1 and theta 2, if these corresponding sides are congruent like so, then we know that theta 1 is actually equal to theta 2. So why is this important in our case, right? Well, here we have this triangle APB such that these two sides are congruent. Therefore, their opposite angles, this one and this one, must be equal to each other, right? So what this tells me is that this angle is equal to 20 degrees. Now, of course, this other triangle, we have the same scenario, right? So we have these two congruent sides, and we have, therefore, that this angle must equal this angle, and therefore this angle is also 20 degrees, right? So I'll go ahead and draw them separately so we can see what we have. So we have these two triangles, 20 degrees, 20 degrees, and therefore, since we know that both of these angles are 20 degrees, and we know that the sum of the angles in a triangle sum up to 180, we know that this last angle must be what? It must be equal to 180 minus 20 minus 20, so it's equal to 140, right? So this image is getting a bit cluttered, right? But I'll go ahead and denote it like so. So this angle and this angle right here, they're both equal to 140, right? So this angle right here is equal to 140 degrees. Okay, so what do we have now? We have that these two orange angles are both equal to 140, and we know that the sum of the two orange angles plus the sum of the angle x must equal 360, right? So we know that 360 must be equal to one of the orange angles plus the second orange angle plus x, right? So therefore, it's pretty straightforward from this point. 360 is equal to 280 plus x. Therefore, x is equal to 80. There you have it. Okay, so for this next problem, we are given that 3x minus y is equal to 12. and then we're asked, what is the value of 8 to the x divided by 2 to the y? So it seems like they give us something and then they're asking us something that is completely unrelated at all to the thing that they originally gave us, right? So they throw out some nice bait here with this saying, the value cannot be determined from the information given. So it can be determined, right? But what are they testing here? So what they're testing here is our recollection of exponent rules, right? So, recall three important exponent rules, right? So 1, 2, 3. If we have some number z raised to the a, let me write that again, z raised to the a, and then all of that raised to the b, that is equal to z to the a times b, right? Also, if we have z raised to the a times z raised to the b, that's equal to z to the a plus b, right? And finally, if we have z to the a divided by z to the b, then that's simply just z to the a minus b, right? So we have to find some way to use this and apply this to the problem that we're given. But it might seem a bit, might seem like it doesn't apply somehow, right? So here in particular, this applies to when you have the same common base, right? But here in this problem, we don't have the same common base. However, notice that 8 is just 2 to the power of 3, right? So 2 cubed, right? So we can rewrite 8 to the x over 2 to the y as just 2 to the 3 to the power x divided by 2 to the y, right? Again, this is just directly from the fact that 8 is equal to 2 cubed. So I replace 8 by 2 cubed, right? And now we can apply our exponent properties directly, right? So first of all, this property 1, we can apply it immediately here. So we get that this is equal to 2 to the 3x divided by 2 to the y. The denominator is unchanged. And then from here, we just apply property 3. So because now we do finally have some common base, right? So this just simply tells us that this is 2 to the 3x minus y, because the 3x here is playing the role of a here, and then the y, of course, is playing the role of b here. So now it finally starts to come together, right? Because 3x minus y, we're actually told what that is, right? So right here, we're told that 3x minus y is just equal to 12. So this entire thing just simplifies to 2 to the 12, which is answer choice A, and we're done. So for this next problem, we're told the complete graph of function f and the table for the values of function g are shown above. They tell us further the maximum value of f is k, and then they ask us what is the value of g of k, right? So it might seem a bit confusing, why am I given some graph of f, but then I'm only given a table for g? How do I connect these two? So we're just going to follow along with the information that they give us, right? So we're told that max value of f is k, right? So the maximum value that f attains is k. However, from the graph, we can see what the maximum value that f attains is, right? So just looking at this, the maximum value that f attains is a value of 3, right? So the maximum value, so max value of f is 3. That's what we see visually from the graph. Well, then k is equal to 3. Quite simple, right? And then we're asked, what is the value of g of k? So k is equal to 3, therefore they're just asking us for what is the value of g of 3. So looking here, right? So the input of g is x, right? So when I see here x is equal to 3, the value of g of 3 is 6. And there you have it. For this problem, we're told that the value of a collectible comic book increased by 167% from the end of 2011 to the end of 2012, and then decreased by 16% from the end of 2012 to the end of 2013. What is the net percentage increase in the value of the collectible comic book from the end of 2011 to the end of 2013? So when you see a problem like this, it's quite easy to get overwhelmed by just, the sheer amount of text in this sort of problem. But what we want to do is kind of abstract the process and learn how to generalize this kind of problem. So what do I mean by this? Whenever we're given some kind of problem where they give us, let's say, an initial price P, and then they tell us that the price increased, so we have some kind of increase by K%. What this means is that we have some new price. So we have some new price P1 that's equal to the original price P0 plus that percentage K. So K, but we're going to write it as a decimal, of course. So we have plus K over 100 times that original price P0. So that's how I want you to think about these sort of problems from now on. Whenever you have some initial price and we're told that the price increased by K%, the way to think about this is you have some new price that's equal to the original price, right? The new price is equal to the original price plus K over 100 times P0. Now, of course, if it decreased by K, it would be the same thing. Instead of a plus here, you would have a minus. So how do we use this, right? So in our specific case, let me section this off to the side here. So in our particular case, there was some initial price, P0, but now with this new price, P1, it's equal to the original price, P0, plus, well, there was an increase of 167%, right? So we're going to have 167 divided by 100 times P0. So of course, this is just equal to P0 plus 1.67 P0. Now there's an imaginary 1 in front of this P0, right? So when I add these two, I actually get 2.67 times P0. Okay, but now we're told after this increase by 167%, there was a decrease of 16%. So now there's an updated price P2, which takes this price P1 and decreases it by 16%, right? So this would be 16 over 100, or I'll just skip straight to 0.16 times P1, right? So 0.16 because we had 16 divided by 100. So what is this? This is just equal to 0.84 times P1. But then we're asked, okay, so what was the net increase from 2011 to the end of 2013? Well, the price at 2011 was the original price, P0. So they want us to write P2 in terms of P0. How do we do this? Well, we know that P1 is equal to 2.67 times P0. So all this is 0.84 times 2.67 times P0, right? So just taking out my calculator real quick to do 0.84 times 2.67. So that gives me, I'll write it down here. So that gives me 2.2428 P0, right? So, but I want to know what the net increase was, right? So you'll notice that another way to write this is P0 plus 1.2428 P0. Because remember, we said that's what it means to increase by a certain percentage, right? So we have P0 plus 1.2428 times P0. This means that we had increase, so we had an increase of 124.28%, which is option A. For this last problem, we're given the system of equations and we're told that A is constant. Then we're asked, for which of the following values of a does the system have no solution? So what I want to do is I want to give a quick recap as to the three different scenarios that we can have when we have a system of linear equations. We can have three different scenarios, right? So in this first scenario, let's say we have our first line, and then we have the second line, and they intersect at exactly one point, and then they never intersect again. So this is the case where there's exactly one solution. The reason that these lines can never intersect again is because they have different slopes. Once they intersect at a particular point, they just veer off in their respective different directions forever. So they only intersect at one particular point. Now for this second case, you can have your first line like so, and then have it be so that your second line is actually in fact equal to the first line. So the two lines are the same, and then therefore they have infinitely many solutions. Now for this third case, the one that we're interested in, right, you have your first line, and then you have this second line in such a way that both of the lines have the same exact slope. So the lines are parallel, right? The lines can only be parallel if they have the same slope. So in this case, they have the same slope, but they have different y-intercepts. Because they have different y-intercepts, we're not in the second case where we have exactly the same line. But the two lines, again, have different y-intercepts, so they're not exactly the same, but they're also parallel and therefore never intersect. So this is the case that we're interested in. So since we want to know something about these lines' slopes and y-intercepts, I want to get both of the equations above in slope-intercept form. So for this first line, it's quite simple, right? To get this in slope-intercept form, I just add 3x to both sides. So I get y is equal to 3x plus 6. And then for the second equation, I subtract ax from both sides and divide by 2. So what this gives me is y is equal to negative a over 2x plus 2, I believe. So then notice, right, these two lines have different y-intercepts. So we're definitely not in the second case where we have infinitely many solutions. So now we just need to find the value of a that makes this slope equal to 3. In other words, we're just trying to find the value of a such that 3 is equal to negative a over 2. We just multiply both sides by negative 2, and then this gives us that a is equal to negative 6, which is answer choice A.